1.
Today we are discussing about the Carnot engine in the thermodynamics. And before discussing about the Carnot engine, first we discuss about some little bit basics on the first law of thermodynamics. So what is first law of thermodynamics? Suppose this is the gas. This is the gas. Let I say that this is the piston. Let this is nothing but the movable piston. This movable piston is connected to a spring. Suppose I am supplying the heat energy. I am supplying the heat externally to the gas. So when the heat is supplied externally to the gas, the internal energy of the gas will increase, and the piston can also able to do some compression on the spring. So when the piston is moving and when the spring is getting compressed, I can say that some amount of work is said to be done by the gas. So now what is first law of thermodynamics? First law of thermodynamics tells that the law of conservation of energy. So what is law of conservation of energy? Suppose I given delta Q amount of the heat externally. When I give the delta Q amount of the heat, this heat is utilized to change the internal energy of the gas. What is delta U? Delta U is nothing but the change in internal energy of the gas. And some amount of work is also said to be done because the spring will get compressed. So whatever the amount of energy that is supplied externally, and this amount of heat energy is utilized by the gas to increase its internal energy, and some amount of energy is utilized in doing the work done. So the first law of thermodynamics is law of conservation of energy. So law of conservation of energy is neither created nor destroyed. That is nothing but whatever the amount of energy that I am giving externally, which is equal to the change in the internal energy of the gas, that is nothing but delta U, and this is nothing but work done, and WD is nothing but the work done. So before that, first of all, when we are discussing about the work done, a change in internal energy, and generally what is the formula for the change in internal energy? Delta Q is equal to F by 2 nR delta T plus nR delta T, and this can be written as F by 2 plus 1 of nR delta T. Okay. So what is N here? N is nothing but number of moles of gas. And what is R? R is nothing but gas constant. R is gas constant. And F is nothing but, this is called degree of freedom. Degree of freedom. So F is the degree of freedom. For monoatomic, degree of freedom is 3. For diatomic, it is 5. So we have for the different gases, we have the different degree of the freedom. So first of all, this is the first law of thermodynamics. Suppose if I am taking the graph between the P and V. If I take the graph between the P and V, what is P? P is nothing but, I can take it as a pressure. And what is V? V is nothing but the volume. Suppose, let I take that this is nothing but P, and this is nothing but the V. Okay. Let I say that I am taking the indicator diagram like this. Let I say that here, this is the initial volume. This is initial volume V1, and here the final volume is nothing but the V2, and initial pressure is nothing but the P1, and final pressure is nothing but the P2. Okay. So I am taking the graph. Of PV. P means pressure. Pressure is taken along the y-axis and volume is taken along the x-axis. Now here, when I am taking here, now V1 to V2, pressure is increasing, volume is also increasing, and can I say that here integration of what is area in the graph? So in the graph, what is area in the graph? Area is nothing but, in the graph, area is nothing but integration of y dx. So dx is nothing but small change along x-axis, y is nothing but y-axis, area is integration of y dx. So here in thermodynamics, what is the work done? I said that delta Q is equal to delta U plus work done. This is the first law of thermodynamics. So in the first law of thermodynamics, what is the work done? Delta Q is equal to delta U plus integration of P dV. So integration of P dV is nothing but the work done. So P is nothing but the pressure, dV is nothing but the change in volume. So P is pressure, dV is the change in volume. Integration of P dV is nothing but it is called the work done. So if I am taking a schematic diagram, now can I say that here volume is increasing and the area under this indicator diagram will give the work done. And here I can say that work done by the gas is positive. So work done by the gas is positive. I can say that this is the work done. Work done is positive. Suppose if I take like this, suppose this is pressure, this is volume. Okay. Now this is indicator diagram. Now can I say that volume is decreasing? So volume is decreasing, and volume is decreasing. I can say that here this is initial volume and this is nothing but the final volume. Volume is decreasing. Now can I say that here area will be work done by the gas is negative, because here area is nothing but it is negative. So here I can take that work done by the gas is positive, and here I can take that work done by the gas is negative. Okay. So basically in the PV graph, what is work done? In the PV graph, work done is nothing but the area enclosed. So area enclosed of P and V gives the work done. Suppose if I take what is cyclic process? So cyclic process is nothing but, suppose for example, if I take this is x-axis, this is y-axis. Now suppose I am taking this is P and this is V. So in the cyclic process, suppose I am taking started from like this, like this, like this. Okay. Now from where I have started, again I have reached the same point. Suppose if I take the coordinates of the gas as here, T0, V0, T0. So P0, V0, T0 is nothing but pressure, volume, temperature. Now this is one process, this is one process, and if you see this process, in this process the temperature is constant, the pressure is constant. Now see here, in this process, what is constant? Can I say that volume is constant? And here in this process, again I can say that the pressure is constant, and here again I can say that the volume is constant. Okay. Now here, whatever the thing, this is P0, V0, T0, the coordinates. Again I am coming to the P0, V0, T0. So when I am coming to the again P0, V0, T0, now this is nothing but it is the cyclic process. So in this cyclic process, okay, so I started from the T0 temperature. Again I am coming to the T0 temperature. So when I am coming to the T0 temperature means what is the change in temperature? Change in temperature is equal to 0. So when the change in temperature is equal to 0, then it is temperature is constant. Temperature is constant means it is an isothermal process. As we know that in isothermal process, in isothermal process, I can say that temperature is constant. In isothermal process, temperature is constant. So I can say that what is delta U? Delta U is nothing but Nr T ln, or I can write it as delta U is equal to Nr delta T. What is delta T? Delta T is equal to 0. So delta T is equal to 0 means, now see here, I started from P0, V0, T0. Again I am coming to the T0. That means change in temperature is 0. When the change in temperature is equal to 0, I can say that delta U is equal to Nr delta T. and delta T is equal to 0, then delta U is also equal to 0. So what is cyclic process means? From where I have started the process, again I am coming to the same process. When I am coming to the same process, the process has started from P0, V0, T0. Again I am coming to the, after completing one round, again I am coming to P0, V0, T0. That means here change in temperature is 0, then delta U is equal to 0. So what is thermodynamics first law? So from first law of thermodynamics, what we can write? Now can I say that delta Q, whatever the amount of heat energy supplied, that is equal to work done plus delta U. That is nothing but delta Q is equal to delta U is 0, delta U plus integration of PdV, because work done I am writing it as integration of PdV, and delta Q is equal to delta U is 0, integration of PdV. That means whatever the amount of heat that is supplied, and that heat supplied is equal to the work done. So in the cyclic process, delta U is equal to 0, and whatever the heat that is supplied externally, that heat supplied will be only converted into the work done. So now I can say that here, this is the cyclic process. In this cyclic process, what is delta U? Delta U is equal to 0. And can I say that here what is work done? Work done is equal to positive, because here this indicator diagram illustrates there is no work, because volume is constant. Here also volume is constant. Now suppose if I take this line segment, now I can say that here this is the area enclosed. Okay. And suppose if I take this line segment, this is the area enclosed. Okay. And if I subtract this area, if I subtract this total area, and if from this area, I mean this area is subtracted from this total area. So if this area is subtracted from this total area, then I am getting the work done. So in fact this area is bigger than this area, then work done will be equal to positive. So I can say that here work done is positive, then work done is positive means heat is supplied externally to the system. So when the work done is positive, heat supplied is externally to the system. Okay. So here, first of all, here pressure is constant. If you see, for example, in this, here pressure is constant. So pressure is constant means isobaric process. And here volume is constant. So here volume is constant. And here also pressure is constant. So now I can say that here, this is a cyclic process. So in the cyclic process, wherever I will start, again I will come to the same point. Okay now. So now work done will be positive and heat is said to be supplied. Suppose if I take this, suppose this is PV, this is P, this is V, and this is a cyclic process. Okay, so this is cyclic process, and in this cyclic process, this is in the clockwise direction. So this is clockwise direction. So in the cyclic process, if it is the clockwise direction, now what is work done? Work done is equal to positive. So if you take the work done, if you take the clockwise direction, then it should be the positive work done. So work done is equal to the positive, and delta U is equal to 0. Then I can say that it is supply. It is supply. So we have to concentrate on this. And suppose in the cyclic process, in a closed loop, so always the cyclic process will form a loop. Suppose if the loop is in the anti-clockwise direction, suppose this is the loop is in the anti-clockwise direction. So anti-clockwise refers, that is work done is equal to negative. So when work done is equal to negative, it is said to be absorbed. It is absorbed. So it is said to be absorbed. Now work done is equal to the negative. And anyhow, in the cyclic process, change in internal energy of the gas is 0. So what is delta U? Delta U is equal to change in internal energy. So change in internal energy of the gas is 0. That means internal energy neither increased nor decreased. Okay. So in the cyclic process, you will get a closed loop. And sometimes you will ask the question like this. For example, suppose I am taking the Vp graph like this. Suppose this is V and this is nothing but the P. So if it is V and if it is P, now can I write as here? Suppose this is in the clockwise direction. So even it is clockwise direction, you have to take the work done will be negative. So here work done is equal to negative, and anyhow delta U is equal to 0 because it is VP graph. Suppose if I take this is the PV graph, now this is P, this is V, and suppose this is the clockwise direction, then work done is equal to positive. So here work done is equal to positive. So work done is positive, and anyhow delta U is equal to 0. Okay. So a closed loop will illustrates the cyclic process, and in the cyclic process work done will be equal to always, it may be positive, it may be negative, but change in internal energy of the gas in a cyclic process will be always is equal to 0. And you have to concentrate on the graphs when PV graph is given and clockwise direction, work done is positive, and in the volume pressure graph is given and area formed by the loop that is illustrating the work done, and this work done will be equal to the negative, and anyhow delta U is equal to 0 in a cyclic process. Okay. Suppose, for example, if I take like this, for example, suppose this is a cyclic process, let I say that here this is V1 volume, let I say that this is nothing but the V2 volume, and example, this is P1 pressure and this is nothing but the P2 pressure, and I am taking the PV graph. So when I am taking in the PV graph, okay, so now this is V1 and this is V2, and this is nothing but P1 and this is nothing but the P2, and now suppose he will ask that sometimes the question, what is the work done? So what is the work done? What is the work done means actually, what is the work done? For example, now this work done is equal to, now let I say that this is R, radius of the circle. So radius of the circle is nothing but, what is work done? Work done is equal to, now I can write it as, suppose if the process is like this clockwise direction, now work done is equal to area enclosed. Now thus it is nothing but the area of circle. So what is area of circle? That is nothing but pi r square. So area of the circle is equal to pi r square. So pi into r square I can write. So pi into r square I can write. So r will be given. Now suppose this is V1, and from here to here this is V2, and V2 minus V1 is nothing but the diameter of the circle, and if you half the diameter of the circle you will get the radius, then pi r square is nothing but the area of this closed figure, that is nothing but the area of the loop, and as it is the clockwise direction the work done will be equal to positive. And suppose if I take here, then you can take work done is negative because it is in the anti-clockwise direction. And suppose sometimes we will do like this, the length of the scales will be different. For example, suppose I am taking the like this, when I am taking like this, now suppose this is nothing but the V1 and this is nothing but the V2. Okay, this is V1 and this is V2, and let I say that here this is pressure P1 and this is nothing but the pressure P2, and if you are observing here, this is V2. If you are observing here, this is V2, this is V1, and here area is nothing but area enclosed by the ellipse. This is not a circle. This is the ellipse. That means here what is the change in volume? Can I say that V2 minus V1? And what is change in pressure? That is nothing but P2 minus P1. And if I draw this one, this is nothing but P2 minus P1. Let I say that this is nothing but B, and let I say that the area of ellipse can be given as pi into AB. So A is nothing but the length of semi-major axis. Semi-major axis is nothing but this one. That is nothing but V2 minus V1 half. That is nothing but V2 minus V1 by 2 into semi-minor axis. That is nothing but P2 minus P1 by 2. And this can be given as pi by 4. and P2 minus P1 into P2 minus P1, and this is nothing but the area which is equal to the work done. So sometimes you will get directly ellipse. Ellipse is nothing but pi AB. You can write it as pi AB is nothing but P2 minus P and P2 minus P1. Okay. Now here, suppose if I take now suppose if I take like this, I have taken the different scale. Let us say that this is pressure. This is nothing but the volume. Now this is pressure, this is volume. Okay. Now let us say that this is V1 volume, this is V2 volume, and this is nothing but P1 pressure, and this is nothing but the P2 pressure. Okay. But here I am taking the what is work done, you will ask. So what is work done? So find work done. So find work done. Option pi by 4 P1 minus P2 whole square. Option B pi by 4 V1 minus V2 whole square. Option C pi by 4. I can write it as pi by 4 P2 minus P1 into V2 minus V2. And option D, I will take it as none. Okay. So find the work done. Pi by 4 P1 minus P2 whole square. You can take P2 minus P1 whole square. P2 minus P1 whole square. And I can write it as V2 minus V1 whole square. And pi by 4 P2 minus P1 into V2 minus V1. And option D is none. So this is the long back previous question asked. So how we will solve this? Now suppose actually this is the circle. So it is appearing like a circle. Actually, suppose if I take a scale like this. Okay. Now here what is, this is initial volume. V1 is initial volume and V2 is nothing but the final volume. And suppose the change in volume. Okay. And here this is the change in volume and this is referring change in pressure. So this is change in pressure and this is nothing but I am saying the change in volume. Suppose I am taking the graph. As I am taking the graph, the dimensions, I mean the scale of the graph, I am along the x-axis and along the y-axis if I take differently. Okay. Suppose let I say that this is equal to 5 centimeters. In the 5 centimeters, the change in the volume is equal to the 10 liters. If the change in volume is equal to 10 liters. Suppose if I take change in pressure is equal to 20 atmosphere in 5 centimeters. So as I am taking the graph, see here, in the 5 centimeters I am taking the change in atmosphere is 20 atmosphere and here I am taking the change in volume as 10 liters. So actually it is appearing as a circle, but actually it is an ellipse. So from the options we can go with this is nothing but actually it is ellipse, but it is not a circle. So it is appearing as a circle because as I am taking the scale is 5 centimeters, 10 liters. Change in volume is 10 liters in 5 centimeters. Here change in volume will be 20 centimeters in 20 atmosphere in 5 centimeters. So actually it is appearing as a circle, but actually it is the ellipse. So find out the work done. Suppose if we will ask that find out the work done, and what is the work done? Work done is equal to, just now we discussed pi AB. A is nothing but the semi-major axis and it is nothing but semi-minor axis. Now pi AB, that is nothing but pi into A is nothing but semi-major axis, that is nothing but I can write V2 minus V1 by 2 and semi-minor axis P2 minus P1 by 2. This can be written as pi by 4 P2 minus P1 of into P2 minus V1 and this is nothing but area. And can I say that this is nothing but the work done? So already we know that work done is equal to the area. So I can write it as work done is equal to area. So work done is equal to pi by 4 of P2 minus P1, V2 minus V1. And if you see, some good students will take like this. Suppose if I take dimensionally, so dimension, suppose sometimes you have to check dimensionally also, check dimensionally. Now suppose see here, P2 minus P1, this is nothing but delta P, which is equal to the pressure. What is pressure? Pressure is equal to the force by area. And what is delta volume? Volume is nothing but area into length. So volume is equal to area into length. Now I can write it as, now delta P pi by 4 is constant of delta P into delta V, which is equal to pi by 4 of what is delta V? Delta V is nothing but force by area. Force by area into length. Now can I write it as length, area cancel. So pi by 4 and force into length, that is nothing but force into displacement. And force into displacement is nothing but, I can write it as the work done. So what is dimensionally correct? Work done dimensionally correct is P2 minus P1 into V2 minus P1. So in the diagram, maybe it is appearing as a circle, but actually it is the area because I am changing the space. Okay. So, and you can also sometimes you have to check with the dimensions also. You have to check with the dimensions also. Okay. So basically, whatever the cyclic process we discussed, work done in the clockwise direction in the loop, work done in the anti-clockwise direction in the loop. Okay. So work done is positive for the anti-clockwise direction. Sorry, clockwise direction. Work done is negative for the anti-clockwise direction. So basically here, in the cyclic process, we came to understand that delta U is equal to 0. So first of all, in the cyclic process, delta U is equal to 0. There is only work done. So this work done is, it may be positive. This work done may be positive and work done may be negative. So work done is positive means work is said to be done by the gas, and work is said to be negative means work is said to be done on the gas. And this is nothing but heat supplied externally, and this is nothing but the heat absorbed. This is the cyclic process. So today we are discussing actually about the Carnot engine. So actually Carnot engine, what is Carnot engine? So Carnot engine is nothing but it is a heat engine. It is a heat engine. So Carnot engine is nothing but it is a heat engine. So actually what is the best process in the cyclic process is isothermal process. And in cyclic process, there is compulsory an isothermal process. Okay. Suppose, now let us say that here, now suppose if I take first law of thermodynamics, delta Q is equal to delta U plus work done. Suppose whatever the heat that I am supplied to the engine, okay, whatever the heat that is supplied to the engine, what is delta U? Delta U is nothing but, now can I say that delta U is nothing but, delta U is 0 plus this is nothing but the work done. So whatever the heat is supplied, the same amount of the heat is completely utilized for the work done. So, but only with the isolated isothermal process, it is impossible to construct the heat engine. So, compulsory there is the involvement of the other process also. But if it is the isothermal process, whatever the heat energy that is supplied, the same amount of the work is said to be done. So, the efficiency will become 100%. Okay, because suppose if I take 100 joule of heat energy and 100 joule of work is said to be done. But here isothermal process with isolated isothermal process does not exist. So in the Carnot engine, what we are doing is, so in the Carnot engine, we are doing, first of all, we can also discuss the efficiency of the cyclic process, and after that we can do efficiency of cyclic process. Efficiency of cyclic process. In the efficiency of the cyclic process, for example, suppose if I take a loop like this, okay, this is pressure, this is volume. Let us say that here work is positive, here, and here. This is nothing but the loop. So this is nothing but the loop. And can I say that here? This is pressure. Pressure is constant here. Here volume is constant, and here pressure is constant and here volume is constant. Okay, so this is the loop. Now suppose if I want to find out the efficiency of the cyclic process. So efficiency of the cyclic process, to find out the efficiency of the cyclic process,